This is our last section for Chapter 10, and the title of the lesson is Cofunctions. Cofunctions. So the first line takes us back to a vocabulary word from geometry. Two acute angles are complementary if the sum of their measures is 90 degrees. For example, complementary angles 30 degrees and 60 degrees because they add up to 90. 45 degrees and 45 degrees also add up to 90. 28 degrees and 62 degrees also add up to 90. So those are examples of pairs of complementary angles. So the cofunctions, we've said several times that we have cofunctions, and you can hear it in their names. Sine and cosine are cofunctions. See the word co, the prefix? Tangent and cotangent. Secant and cosecant. So these are cofunctions. Sine and cosine, tan and cotan, secant and cosecant. And here's the big part of the lesson. This is it right here. If two cofunctions are set equal to each other, then we know that their angles are complementary. So let's look at some examples. First, the first part here is that I need to have cofunctions, and I do. Sine and cosine. The second part is that they are set equal, and there's our equal sign. And the third part is that their angles are complementary, 30 and 60. So you can see all the parts are in place there. Sine of 30, actually, if we back up, we know sine of 30 is a half, and we know cosine of 60 is a half. So indeed, the sine of 30 does equal the cosine of 60, and their angles add up to 90. So let's see if we can fill in these other three. First, let's make sure we have cofunctions set equal. So the tan of 20 should equal the cotangent of what? And I know their angles should add up to 90. So if you said 70, you are correct. The tangent of 20 equals the cotangent of 70. Cosine, sine. So the cosine of 80 plus the sine of, well, the sine of what angle? And what angle, if we put it there, will add the angles up to 90. I'm so messing up my grammar, but hopefully you get the idea. My pen's got moved. Let's see what we got down here. All right. The angles need to add up to 90. The angles need to add up to 90. All right, there we go. So this last one here, we have secant, and we're setting it equal to something. Everything's blank. So first, what is secant's cofunction? Cosecant. And secondly, what added to 25 gives us 90? And that is 65 degrees. Okay, so it's pretty simple. The lesson is really all about this. We'll add some twists in it, but basically this is it. So this set of directions says, you know what, let me just move this out of my way a little bit. So I can get to my pen, so I'll put it up there. Or just move that. There we go. There we go. So the directions say, rewrite each function value in terms of its cofunction. Then find the value of the function to 4 decimal places. So first let's go through and write them in terms of their cofunction. So I have cosine of 40. Its cofunction is sine. And what angle would give you a sum of 90? Sine of 50 degrees. So let's go find the value of that. Check your mode. Check your mode. I'm putting in degrees, so I want it to be in degrees. And we're going to do the sine of 50, which is 0.7660. And let's do the cos of 40 too. Cos 40. Oh, 0.7660. So we can see they're equal. You can always do a quick check. Number 2, secant of 70 would equal cofunction of the angle that would add up with 70 and give you 90. Hopefully you can do that in your head. That's 20 degrees. And now, how are we going to do the cosecant of 20 in our calculator? We don't have a cosecant button, but we have a sine button. And all we have to do is flip that. So 1 over 1 divided by sine of 20. And I have 2.9238. If we wanted to check it, how would we figure this one out? Secant of 70, same as 1 over, it's reciprocal function, 1 over cos of 70. Try that one. And alas, it is the same answer. Okay, so there's part A. I'm circling everything now, and part B. Number 3, cotangent is a cofunction with tangent. And 58, and what angle? You said 32, terrific. And try the tangent of 32. I have 0.6249. All right. Number 4 offers a bit of a different challenge because we need an acute angle here. So the first thing we have to do is rewrite sine of 20. And when we rewrite with an acute, that means we're dealing with the reference angle. So draw a little picture. 220 rounds around and terminates here. What is the reference angle in quadrant 3? For 220 then, that is 220 minus 180. And then the sign that we have, the sign of sine in quadrant 3 is negative. So first, sine of 220 is the same as the negative sine of the reference angle. Negative because we're in quadrant 3. Now rewrite that in terms of its cofunction. The cofunction for sine is cosine, and the angle that is complementary is 50. Let's go ahead and put either of those into our calculators. Negative sine of 40. You see that that is negative 0.6428. I'm also going to do negative cos 50. I'm also going to do sine of 220. Just to show that it's equal to negative 0.6428. They're all the same. So we can rewrite our functions quite a few different ways. Let's practice the same thing with 290. We need an acute angle. Go ahead and QRS this. Tan of 290. Draw a picture. 290. Terminates 90, 180, 270. Ooh, in quadrant 4. Bow tie angle is here. So that reference angle is equal to 70 degrees. And we've got tangent in quadrant 4 is negative. All students take chemistry. So rewriting it, negative tangent of 70 degrees. And now put it in terms of its cofunction. Negative cotangent of the complementary angle, negative cotan of 20. Now, interestingly, let's do this the same way. Let's do the tangent of 70. Let's do all three. Tangent of 70. 2.7475 if I round it. Let's do the tangent of 290. Of course, it's still, whoops, I'm sorry, negative. I left my negative off. Negative 2.7475. And how are we going to do the negative cotangent of 20? That would have to be negative cotangent's reciprocal is also tangent, but that angle stays the same. So try negative 1 divided by tangent of 20. And yes, indeed, ding, 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 negative 2.7475. All right. Now these last three are different directions, actually. And these are more along the type of what you would see on a Regents exam. So these directions should say just solve for x. So let me pop this up a bit. There we go. So solve for x. Or whatever the variable might be. Then what you need to recognize, it's not going to be in neon lights, what you need to recognize is that there's a sine on this side, a cosine on this side, and they're set equal. So you need to know, oh, something's set equal, something's set equal, and not just something, but tan and cotan, cosecant and secant, sine and cosine. So in each case, we have cofunctions set equal to each other. When we have cofunctions set equal to each other, we know, let me write this actually. I have cofunctions set equal. Therefore, the angles, or their angles, add up to 90 degrees. So let's just grab out the angles. 2x, adding together with x minus 30, should be 90. And solving that, we have 3x equals 120 when I add over the 30, and so x equals 40. We could certainly check that. Putting that in, up in the original, that would mean the sine of 2 times 40 equals the cosine, move that over, of 40 minus 30. That's 10. And you might just recognize, oh yeah, they're complementary, or you could definitely type this in your calculator, and see that the decimal values are equal. Checking is a good thing. Okay, the other two, let's see. I have cofunctions set equal, therefore the angles add up to 90. Go ahead and solve that. And again, you could check it. Try the tangent of 3 times 18 plus 17 and see if it equals the cotangent of 18 plus 1. Number 8. I have cofunctions set equal secant and cosecant. Therefore, their angles add up to what? Complementary. Complementary. Add up to 90 degrees. So we have 12x plus 10 equals 90. 12x equals 80. Divide by 12 to get x alone. And 80 divided by 12 is 6.6 repeating. Or if you'd like, 6 2/3. Okay? We're going to have a little quiz tomorrow when you come into class. And the quiz is way back from the beginning of the unit. The quiz will be on converting degrees to radians. Okay? Converting degrees to radians using the formula S equals theta R and finding exact values of some of the trig functions. So I would recommend that you go back and look over some of those notes. It's a short little quiz, and I'll see you then. Mrs. Raccoon's kids have the quiz. I don't know about Mrs. Johnson's kids, but I'll tell her I put this on here. Bye.